In this video, you will learn how to factor quadratic equations using the AC method. A quadratic function is a function with a degree of 2, which means that the highest degree is equal to 2, or the highest exponent. There are several ways to factor quadratic equations, but in this case, we will use the AC method. So what is an AC method, and how do we do this? So the first thing we do is we identify the coefficients of the quadratic equation. So we have A, B, and C. So we identify the values of A, B, and C. And this method is usually applicable to those quadratic equations with values of A not equal to, or when the value of A is not equal to 1. So all we have to do is we multiply A and C, and then we look for, okay, A and C, so the product would be AC. Then we look for factors of AC that when we add them up, it would equal to B, which is the coefficient of the middle term. And then we fill in that in the middle term, and then we factor the split quadratic by grouping. So let's try solving some problems. So let's say we're given this quadratic equation 2x squared plus 11x plus 12 equals 0. Take note here that A is equal to 2 and which is greater than 1. So A is equal to 2, B equals 11, and C equals 12. So we apply AC method here. So we multiply A and C. So that would be 2 times 12, which is equal to 24. Now we know that the product of coefficients A and C is 24. So we look for factors of 24 that when we add them up, it would equal to 11, which is the coefficient of the middle term. So factors of 24 are 1 and 24, 4 and 6, 2 and 12, 3 and 8. Okay, because when you multiply them, they would equal to 24. So 1 times 24 is 24, 4 times 6 is 24, 2 times 12 is 24, and 3 times 8 is 24. Now let's choose which of these factors that when you add them up, it would equal to 11. So 1 plus 24 is not 11. 4 plus 6 is 10, which is not equal to 11. 2 plus 12 is 14 and not equal to 11. How about 8 plus 3? This is equal to 11. So we will choose 3 and 8. So that means we split the middle term as 3x and 8x. So we just have to copy the first and last terms. So that would be 2x squared plus 3x plus 8x plus 12 equals 0. And now we group them, all the terms. So we group 2x squared and 3x together plus 8x plus 12 equals 0. And then we factor out the common factors. So the common factor here in the first expression is x. So we're left with 2x plus 3 inside of parentheses. And then the common factor here is 4. And then we're left with 2x plus 3. Then equals 0. Okay, notice here that the common we have a common factor, which is 2x plus 3. So we can group x and positive 4 together. So let me delete this. And we can group x and 4. So that would become x plus 4 times 2x plus 3 equals 0. Now these are the factors of 2x squared plus 11x plus 12. And we just have to equate each of the factors to 0 to solve for the value of x. So that would be x plus 4 equals 0. And then we subtract 4 from both sides. Therefore, x here is equal to negative 4. That is one of the values of x. Then the other x is 2x plus 3 equals 0. Let me delete this first. Then we subtract 3 from both sides. This cancels out, so we have 2x equals negative 3, and we divide both sides by 2. Then x is equal to negative 3 halves, or negative 1 and 1 half. Therefore, the values of x are negative 4 and negative 3 halves. There is another approach to this. The same method, the AC method, but a different, slightly different approach. So first thing is we neglect 2 here. We copy x squared plus 11x, and then we multiply 2 and 12. A times c, which is 2 times 12, that is 24. And then we add 24 here. Right? Then we look for factors of 24 that when we add them up, it would equal to 11. Previously, we used the factors 3 and 8. So we can write the factors as x, this is plus 8 and plus 3. All right. Take note that we neglected the coefficient of the highest degree, which is a, and that is equal to 2. So we have to divide the factors by 2. Then now we have x plus 8 over 2 times x plus 3 over 2. So this is just x plus 4 times x plus 3 halves equals 0. And then we equate each of the zeros, or the factors, to 0 to solve for the value of x. So that would be x negative equals negative 4, and the other one is x plus 3 halves equals 0. X is equal to negative 3 halves. So we get the same answers. Now let's solve another problem using the AC method. Let's say we're given this quadratic equation for x squared plus 9x minus 9, and then we equate this to 0. So we multiply a and c. Here our a is 4 and c is 9. So this is just equivalent to 36. Now we look for factors of 36 that when we add them up, it would equal to 9. So factors of 36 are 1 and 36. 4 times 9, 12 times 3. Okay, let's take a look when, let's check when we add them. 36 plus 1 is not 9, 9 plus 4 is not 9, 12 plus 3 is not 9. So 1 should be negative. Let's just choose 12 and 3. And 3 should be negative because the coefficient of the middle term is positive. So when we add 12 and negative 3, this would give us an answer that is equivalent to positive 9. So therefore, we can use 12 and negative 3. Now we just have to copy 4x squared, and then we split the factors 12 and negative 3 plus 12x minus 3x and minus 9 equals 0. Then we group the two terms, this one. So we can group them. This would be 4x squared plus 12x minus 3x plus 9. Then we factor out the common terms. The common term here is 4x, then we're left with x plus 3 inside the parentheses. And here is 3, then we're left with x plus 3 equals 0. Okay, take note here, or notice here that we have a common factor here which is equal to x plus 3. So we can split them. And then we group together 4x and negative 3. So this would become 4x minus 3 times x plus 3 equals 0. Therefore, the factors of 4x squared plus 9x minus 9 is just 4x minus 3 times x plus 3. So you can always check this by using the FOIL method. If when you multiply the factors, it would equal to the original equation. And now we equate each of the factors to 0 to solve for the value of x. And this would become the value of one of the x's is 3/4 and the other one is equal to negative 3. So that's how to factor quadratic functions or equations using the AC method.